Hello everyone, thank you very much for coming to our first Nerd Night at Hardware Meetup. Great to see you here. Put up your hand if you've been to a Hardware Meetup event before. Cool. Oh, like kind of half, and then the other half seems new. Interesting. Well, for those of you who haven't been before, so we've been running since 2016, and we're all about bringing people together to showcase amazing companies working in different areas of the hardware space. So our typical event is quite different. We usually have three speakers working from different companies and startups come and talk about their journey with making their products. But today, based on two suggestions from the audience, we're actually going to do something else, which is getting the audience to come up and talk about their personal projects that they're working on for fun. First of all, a big thank you to our sponsors. First of all, Outset, so that's the space we're in today.
I don't work for Outset itself, but I work for Respirac, that is a company based in Outset. And Outset is kind of this building that is a co-working space where a lot of startups are here to developing new technology. And as you can see, we have technology from different things, construction, robots, healthcare, biotechnology. So it's pretty cool to be here.
I'm Brent with GPC Electronics. We're a contract electronics manufacturer. So we build electronic things for other people, mostly industrial products, power electronics, industrial controls, space, aerospace, defence. We've got a factory down in Christchurch with about 75 people. We can do PCBAs right through to complete box builds. And twice a fortnight, I've got a desk just on the other side of this wall. So I'm up here for 3 or 4 days a fortnight at Outset.
Awesome. Thank you, Brent.
Thank you.
Hi, I'm Gordon from Blender Design. I'm here with Hugh. We are a product design and development consultancy, helping people realise their ideas and turning them into reality. We do a huge range of products, anything from commercial furniture, consumer electronics, ag tech, medical devices. So if anyone's got need any help or any kind of advice, we're happy to have a chat.
Cool. Awesome. I'm Mikayla Stokes. This is an inspirational presentation I gave to some students for Women in Engineering, so we might skip through some of them. There's a picture of me as a baby. I used to not like science and tech, and then when I was 12, I went along to a robotics competition, and I really enjoyed it. And then I realized that maths and science is actually really cool because you get to make robots and also solve cool problems to help people. So there's me with one of my robots back in the day. I started getting into doing inventing competitions. There was this really cool inventing competition called Bright Sparks that had been running for 20 years. I don't think they run anymore. I think they kind of died down during COVID, but they were really cool. So first, when I was 15, I made this IoT pollution sensor, and I made these little boxes that you could put in different areas of Auckland. You could put one inside your house, you could put one outside your house, and you could detect the different levels of particulate matter from carbon, which was quite cool. And then when I was 16, I made this automated vertical garden using hydroponics. It looks cool. All those plants were just put in there. They were not grown in there. I found I had really big issues with equilibrium problems because they were at, the two pipes are at different heights. So the only thing it could do would flood my parents' basement, basically, which my mum was not very happy about. But I had this whole system that would measure the amount of nutrients and the pH and then add different fluids to balance everything out. So that was also a really cool project that I also entered into Young Enterprise, and I got a lot of cool awards for that, which is awesome. And that's kind of got me to liking engineering. And then this is a really cringe thing that I was on a few kids' TV shows. So I even have braces in this photo. So this was so there's a guy on YouTube called Joseph's Machines who makes Rube Goldberg machines that, you might knock over a domino, which rolls a marble, which will then pour you a glass of juice or something. So this was a kids show we did with TVNZ where we tried to solve kids' problems with Rube Goldberg machines, but would often make the problems worse. So this was some stuff from that, and I was also on a different show called Fanimals with did anyone know the show Let's Get Inventing? Anyone? You remember that? So that's Dr. Robotech, Chris Chitty. So I was on the show with him, and we made a robotic monkey for kids to have a robotic pet, but we just went and terrorized kids in a petting zoo. It was great television. And then I did mechatronics engineering. I graduated 2.5 years ago. And when I was at uni, I made this light-up dress over the 4 years. Those are 2 different iterations, which is pretty fun. I was going to wear it tonight, but I forgot. I wore it to the wearables event that I hosted a few months ago. And then also I make 3D printed earrings for fun. It's kind of one of my side quests. I have not done it in a while. My friend has a resin printer, so it's quite cool experimenting with the different ways you can 3D print things. But so yeah, made some eggs, some cheese, some blue cheese. And then now I work at Crown Equipment, so I work making autonomous forklifts and just working around like automation and perception, which is pretty cool. And that's a irrelevant slide. Anyway, my last thing I'm going to say is now I'm kind of thinking about doing a new personal project where I used to do a lot with science communication with kids about teaching about robotics and tech and electronics. I did it before COVID, but COVID kind of killed everything. So I'm thinking about getting it started again. So a lot of these, I kind of want to run like small workshops with schools, especially local libraries, where we can kind of recreate like lower level versions of my inventing projects, where kids can learn about inventing and how to make stuff to solve problems with engineering and electronics. Because yeah, I found at school I never really could see the application, but with inventing projects, it'd be like a very obvious choice of how I can help people and my future career. So I'm gonna want to set up these kind of kits and do some like demos with schools. So my age range is probably around like 11 to 15-year-olds. That's kind of the group I want to target because the younger kids get excited about everything, but it's kind of like the kids in the middle that need the most support. So yeah, that's something I'm going to start doing at some point, maybe later in the year. So maybe if you have a kid in that range, maybe if you are interested in being involved or helping out, I could definitely do with some help for that. Yep. Sweet. That's me. Thank you.
Hello everyone, I'm Alex, founder of Securichair. Our thesis is that humans are fallible.
Absolutely.
The question is, did you lock your computer? That isn't a rhetorical question, that's a real question, because no one actually does. Everyone just walks away. That is a SCIF. That's a secure information facility where people handle the most sensitive of classified data. I was in one of those with some UK eyes only data and some people who were not British. And my colleague kept forgetting to lock his computer, and I had to do it for him over and over again. So I thought I would automate the whole thing. Securichair eliminates this problem. You can't leave your screen unlocked. Every time you leave your seat, it just triggers the lock on your computer. It's a pretty simple device. That's all it does. So we've had a little go with it in a GP clinic. That is a GP friend of mine, because he said the same thing. He forgets to lock his computer, and he doesn't want the secret, patient data to leak. But what he said to me was, like, he wants to lock it and he aims to lock it, but when there's an emergency and someone's having a heart attack in another room, he just runs. So it automates it, solves the problem. But what he actually found was that he's getting up and getting down to examine the patient and then type his notes. So the automation was actually super annoying. So my product made his workflow way worse. And the product was quite expensive, and it was hard to fit, and it was heavy, hard to ship. So I've been working on it for 10 months and have made zero money. In fact, I've lost lots of money because I'm not at work, and I'm very grateful to my wife. So I made this instead. This is a big red button. You smash that, it locks your computer. It's way simpler. But the doctors actually quite like it.
That's great.
Yeah. I still think there's a great use case for the Securichair, but maybe that's just a sunk cost fallacy.
Different customers,
different
right?
Customers,
Different
exactly.
Things, so.
Yeah, so I think, I'm from the defense world, and I think there's a really good application in defense and in civil service and across government. But for commercial applications, the big red button is probably the one. We're looking for organizations to pilot Securichair, because we've had it used by a doctor, we've had it used by a startup, and the university is looking to use it for their secure labs. But what we'd really like is a sort of big name brand organization to use it and go, yes, we love this. It's the best thing ever, and we can shout about it. And then I can stop losing money. So if you know anyone who is in a big name brand organization and is a CTO or a chief data security officer, I would really love to have a chat with them. So that's my contact details.
Awesome. Thank you, Alex.
Thank you very much.
Could you just pair it with something that would make it easy to unlock? Was my
Yes, I absolutely could do that. Yeah.
All right, thanks.
How about some sort of nearish field RFID?
So that product exists in the market.
Okay.
And it's a really good product.
Okay.
It's great, but here we go. It
what's the
requires
but?
you to wear a special tag around your neck. So it's
I
not
think most
idiot-proof.
people in those sort of situations have to wear a special tag anyway, like to get in the building or to...
You'd be surprised.
Okay.
Yeah, especially in a hospital setting or in the defense setting, actually, my experience has been that requiring the user to do anything makes the system fall down. So the whole point of the chair is it's completely idiot-proof. You don't even have to know that you're using it.
Sure.
And there is obviously a perhaps worrying concern about tracking, how much bum-in-seat time there is. Your HR department could see it from that angle, or they could see it from are they standing up enough?
What if I switch chairs with my neighbor and then I unlock his screen?
Yeah. So this version is wired, so you can't do that. Because lots of high security environments actually don't like wireless comms at all. However, the wireless version, there's going to be a proximity-based syncing thing.
Could I suggest using AI to detect different butt prints?
I fear there may be some privacy issues.
What if it remembers the weight of the person that was sitting? Because obviously it's going to change over time you go pee and but
I really don't want it to trigger the unlock because someone of a similar weight could trigger that. But I like the idea of the AI butt print.
What about competition from human presence sensors?
Yes, they are another way of doing it, but they are sort of imperfect. Microsoft has ones built in to the camera, and there's various infrared ones, but they can detect the presence of someone who isn't actually the user of the computer, so they are cheaper and easier to implement, but less robust. So they're definitely a valid solution in many cases, but in the hyper-secure environments, they're not really.
Cool. Awesome.
Thank
you
you for
very
having me.
much.
Hi everyone, my name is Sophia. My pronouns are they, she. As a quick introduction, you've probably seen me around this space before, usually holding a camera, including today, so I'm a bit multitasking today, so sorry I'm a little bit frazzled. But yeah, I'm here to present my little project, which is an interactive LED display featuring vintage slide films. It's on the table. I'm really sorry if you can't see it. Unfortunately, when I made this, it was during my graduation ceremony back in May. So I literally went home from my ceremony and soldered for 5 hours. So really sorry, it's not very transportable, but you're more than welcome to come see it afterwards and try it out.
It looks like any normal prototype to me.
It's very much a prototype. So a little bit more about me. I did my Bachelor of Engineering also in mechatronics, but I graduated this year. So I finished very recently, but I'm also a freelance photographer and videographer on the side. I do a bit of multimedia art. This is sort of one example of that. So the main thing that I'm going to be preaching about in the next few minutes is intersection of STEM and art, because it's basically my whole shtick. And I put up my website and my Instagram, my public sort of creative one, if you're interested in following, but I also made some handmade little business cards if you want to take one after as well, which also has those details on there. Cool, so a little bit about the project. It's going to be very concise and surface level, so sorry I can't get into all the nitty-gritty details in this time frame. But as I mentioned, interactive LED display essentially uses proximity sensors, specifically time of flight sensors. So if you don't know how this works, it essentially shoots out a little laser that reflects back from the object, and the time it takes to reflect back is used to calculate the distance to the object. individually addressable LEDs. It's kind of your standard like strip lights you might see in a bedroom. And a microcontroller just to consolidate all the sensor information and tell the LEDs what to do. And then the slide films are antique ones from an antique store. But I want to eventually upgrade this to be a larger wall and maybe include film negatives that are like maybe contributed from people I know or people around Auckland or New Zealand, I think just to add sort of a more personal touch to it. And parchment paper behind the slide films to diffuse the light. So this looks a lot better in low light settings. In fact, I have a photo there because you can't actually see the negative until you put your hand in front of it, which is really cool. Adds sort of a storytelling component. But I'll really quickly, for those who can see, essentially, it lights up in different spots if I wave my hand, and you can see the light up. I have a video of it in the dark later that I can show on my phone if you'd like. Just for the sake of time, I'm going to very briefly go over like the more artistic design perspective when I was creating this. So as I mentioned, I'm very big into STEM and art, sort of the intersection there. My dream is to work in the exhibition design space, and in fact, for the rest of the year, I am going to be working in that space, which is really exciting. But when I started this project, it was sort of that wanting to explore that space, especially with like how technology is used in things like public-facing exhibits, like museums or art galleries, and wanting to incorporate more active interaction with those kind of projects. So that's why I have a note about passive versus active interaction. So if you've ever gone to like a museum or an art gallery and you are maybe just reading something about something, you're not necessarily changing anything about the display or whatever you're viewing, that's sort of more passive interaction, whereas this is like you're part of the exhibit, you're actively changing something, and therefore that's much more active interaction, which I think is really good for engagement and learning, very active learning. So that's kind of what I wanted to explore here as well. And yeah, human-in-the-loop design is sort of just relating it back to my degree, kind of like a control systems perspective, if you're familiar with like standard feedback loops, having your sensor, your observation, and then your actuator, your output, your desired output versus what actually is the actual output, and then the error from there. But in this case, it's kind of inserting the human in that loop, where in this case, we're the actuator, we're actively changing things, and then we can see the output and change our action to get a desired output. Yeah, cool. So a little bit about the motivation behind this project, because it wasn't just exploring exhibition design, it was also as part of a wider passion project of mine that I've been working on this year, which is Resonance. It's a planned STEAM exhibition in Auckland, planned for mid to late next year. And it's funded by the Blackbird Foundation. So if you've heard of Blackbird Venture Capital, this is their charitable branch. And through that, they have a program for people ages 18 to 25 to help fund passion projects of theirs with microgrants, and that's the ProtoStars program. So I initially got that funding back in March, and then I created the prototype here in April and May as part of that. So the larger version of this will likely feature in that exhibition, but as part of the wider exhibition, I'm essentially having more people involved, Mikayla being one of them. So likely about 5 to 7 artists creating works similar like this with different technologies, STEM concepts, and artistic perspectives, and then promoting that sometime next year to essentially hold a big exhibition. Yeah, so, and on that note, this is sort of the action slide, like what you could do to help support if you're interested in these kind of things. I do have room for 1 or 2 more artists, so I'll be 1 more minute. 1 or 2 more artists to be involved. If anyone here is interested or knows someone who might be interested, really there's no prerequisite other than just having some background in STEM and technology and having an interest in art. The QR code there takes you to my website page specifically talking about the project, and there's a link to the application, and the applications will close at the end of the month. My Instagram is also there for the project, that's at resonance.nz. If you want to follow and stay up to date with the project and find out when the exhibition is going to happen, definitely please follow and share. That's probably the biggest way to help support the project, which doesn't really require much other than just following and staying up to date. And share with people who who might be interested. I think especially like young kids or high school students or even just working engineers or people who don't necessarily have a background in STEM who want to learn more about it would find this really, really cool, I'm hoping. And finally, although this is on the slide, if you know anyone who might be keen to support through monetary means, through funding or sponsorship or even a collaboration with a company, I would definitely be interested in talking about it as well, just because I'm in the stage of just trying to find funding to help secure a venue and support the artists who are going to be part of the project as well. So that's pretty much it from me. If anyone has any questions, I can answer them out, or also please do talk to me after if you're curious and want to hear more about all of this.
And we'll definitely promote it. How we meet it, we'll tell you all about it. Yeah. Cool. Thank you so much, Sophia.
Hi everyone, my name is Mikesh Patel. I'm the founder of a company called Automated. About 10 months ago, I think I came to one of these hardware meetup events. I mean, I've attended pretty much everyone before that as well. And after that event, I basically went back to my lab and thought of just starting my side project that I've been sitting on for quite some time, and started experimenting with 3D printers. So bit of a background story. I've been part of the 3D printing industry for about 10 years. 10 years ago, I quit my job, started a store called Bits for Bots that supplies 3D printing products in the market. Since then, I started another venture where I tried to teach kids robotics and coding in the classrooms, but COVID was basically anti-hands-on education. So at that point, I shut it down. Probably 2 years after that, I started another project, which is manufacturing of 3D printers in New Zealand, Australasia market. But the weekend that I launched that project was the same weekend a company called Bamboo Lab launched from China. And I was the first one to get the machine in the country. I was like, these guys to be kidding themselves, trying to promise the speeds they were promising. Tried and tested the printers and decided that I'm never going to meet that benchmark, so shelved that project. Ever since then, I've just been looking for that next project that really, intrigues me and gets my interest into building something. And as a part of Bits for Bots, I also run a 3D printing service where we provide custom 3D printing service to anyone and everyone. And I realized that since the printers have gone so fast, the print jobs usually finish in like 2 to 3 hours or 4 hours. So once I leave my office after 5 p.m., there's no control I have over my printers, and I've got about 20 of them at the office. And I thought I really wanted to automate this. So I decided to just go to this event called TCT Rapid in US to check out what's out there in terms of automation, and found two of the biggest companies. One is Prusa and the other one is Mosaic, and they offer this solution called AFS, basically automates your 3D printing process. And the starting cost was, each of them was about 80,000 USD. And I said, yeah, that's a cool solution, but I wanted something that was affordable and it doesn't lock me into a solution that only works with their system. So came back, started working on this project, put up a team of just 2 of us, started working in the background, pulled apart an old 3D printer and turned it into a 3-axis motion system that allowed us to automate some aspect of it. Kept on working on that, and after 2 months we had an idea, a project, and a business plan around how we can scale up this solution so that other people can take advantage of it. And there was the birth of basically Automated. Automated for automation and 3D for 3D printing. So I imagine some of you might have used 3D printers before. Show of hands if you have used 3D printers before. So you might be aware that once the 3D printing process, the printing finishes, you gotta grab the build plate, get the build plate off, get the part off the build plate, store it somewhere, clean the build plates, put an empty one on, and then restart the process. That basically requires human intervention to clean those build plates. And that is something we wanted to solve when we started this project. So after 6 months of R&D and stuff, we finally launched our kind of first kit set. There was a prototype that we made and launched a Kickstarter on Kickstarter just to get people's interest on whether there's interest in something like this or whether we're on the right track in terms of the product strategy or the market strategy. And as of last month, we have successfully raised about $85,000 on Kickstarter and sold our first 150 kit sets. I think 2 in New Zealand. Thank you. Sadly, we just sold 2 in New Zealand, but the rest of them US and Germany and Europe and whatnot. So we're in the process of fulfilling those orders and getting our beta testers to test this out solution. So who is it made for? It's basically not just for big enterprises like Toyotas and stuff who are making parts for cars industry or high-value products. This is for people who might be making keychains, key rings, whatnot, and running those print jobs to get production runs out of them. Also, institutions. We realize that when the project deadline is near for university projects, we get line of students approaching us that we need this printed today and now. And sometimes we get a file at 6 p.m. and sometimes say at 2 a.m. So we thought, why not create a system that basically allows students to load their files whenever they want, process the files, approve them for printing, and in the morning before the technician comes in, the prints were ready. So automating the whole workflow. So it's made for institutions, it's made for small businesses, it's made for hobbyists, because you can literally buy this kit for $500 and build it yourself, modify yourself, customize yourself to suit your basically printer and need.
With the red hair.
So while that happens, so it basically sits next to your printer. It's a rack system on the side of it. In this kind of configuration, it's about 400 millimeters high. It can hold 6 bill plates on them, so you can continuously run, let's say, 2 empty bill plates and 3 or 4 other print jobs you can line up. And usually if you, there it is. So once the print finishes, it automatically opens the print door, grabs the bill plate, takes it to the rack, would choose the empty storage rack, stores it onto a rack, would go and grab another empty bill plate that you've placed, puts it onto the printer, and it closes the printer door, and off you go. So it basically automates the whole process. It takes about 3 to 5 minutes for that to happen. So there was a hardware part, and I knew that hardware part was going to be somewhat easy coming from a mechanical background. It simply uses just the 3 motors and a Raspberry Pi and an Arduino board. But the software side of things, where it connects to all the printers, it allows you to basically line up the print jobs from wherever you might be. It allows you to run not just 1 or 2 printers, but 200 printers if you really wanted to. There was a bigger challenge. So we went around and created something called Auto Engine, that basically a web platform allows you to connect your printers with this automation system and run your 3D print farm workflow. How it works, basically, it comes in a kit set version right now. You print your own parts, put it together, assemble it, and connect with Auto Engine, and off you go. Takes about 3 hours to assemble a kit set, and probably another 2 hours to set that up with the Auto Eject. So yeah, about 3 to 5 hours process, but we are working on an enterprise model, which would come in a plug-and-play solution. You basically take it out of the box, connect it with 2 cables, and off you go. While we're working on this, I think I've been a kind of person who's always struggled with, if you try to put me in a box, I'll try to bounce out of it. And when every solution I looked at out there in the market, they would try and lock you into their own proprietary system or a printer, and that really bothered me. So I wanted a system that basically was compatible with any printer out there. So with this system, that's the only system that exists in the world that's compatible with every printer brand out there. You're not locked into any systems. You can basically have your old Ender 3 printers or the latest and the greatest Bamboo Lab printers. They all kind of work with them.
The $80,000 thing you were talking about earlier, is that also compatible with all printers? Or
it comes with the printers in them, and it's a completely proprietary system.
Oh, okay.
Yeah. As a part of this, we always, as a part of Bits for Bots, I think we were always in touch with some of the good manufacturers around the world, and LDO Motors is one of the biggest manufacturers for stepper motors in the industry, and they came on board and said we would fulfill your kit sets and manufacturers on behalf. So that made things easier. Once I've got the BOM ready, I basically pass it on to them. They give us a cost, we put our margins up, and off you go. Timeline-wise, we started as September, November last year. We have done our Kickstarter launch so far, and Kickstarter fulfillment will probably begin in about 6 to 8 weeks. And we're planning on launching a prototype for the complete automated shelf system, which would have 6 to 8 printers, which would be one-to-one compared to with AFS system or Mosaic system for less than $10,000. Media coverage-wise, I've been to TCD Rapid last year, as well as RipRap Festival, which is the biggest festival for 3D printing in US, showcase this project and get some really good reviews. We just want to make sure that we're on the right track and we're developing a product which is serving a purpose and solving a problem overall. About us, we're a team of, I'm a mechanical engineer myself. About 10 years ago, I started this. But I graduated in 2012, so it's been a while. I've got another partner who's a software engineer, who's a software dev at another company. So right now, it's only me who turned up here because the other 3 are working on the project at the office after finishing their work day job after 4:30. So this is a regular kind of timeline. I would probably wake up at 12 o'clock, come to office, make sure that I can stay up till 2, 3, 4, and kind of work on this, hence the late night emails. As a part of this journey, last 8 months, I kind of really haven't eaten at home, or I've got a 2-story house. Upstairs is a lounge. I haven't seen the upstairs in 6 months. So it's been a bit of a journey, but it is what it is.
Startup life.
Yep. Our mission is to basically automate 3D printers and basically make it affordable, accessible to even the small businesses and small players in the market. Yep, that's just us. Kalpesh is co-founder. We had a third person who has dropped out, but yeah, that's two of us for now, and we have a team of 2 more engineers on board and a marketing person who does marketing and social media for us. And yeah, that's us automated.
For your Kickstarter, do you have any, like, are you producing more kits than the Kickstarter is providing? Like, for example, if someone in the audience today was interested in getting one, are they able to jump on board?
Yeah, for sure. We only got order for 150. Initially, we thought over our head that we would probably just sell 1,000 of them. We didn't. But we're getting probably at least about 300 more produced on the side. So we would have extras because we didn't get the beta test out in the market soon enough that people actually don't really have experience of using this outside of us. So we are testing them right now, and more content will flow out in the market. And once that happens, we'll get more and more people coming on board. So we are producing more than what we need. And yeah, if anybody's keen, just let me know. And if anybody is keen to come on board as beta testers for the industrial solution as well, let us know. We'll be more than happy to work with you side by side.
How do you stop the build plates from flexing and everything from falling off when you pick the build plates up?
The blue build plates you saw on them, which is BQ ones, that's made by BTT company. Initially, I thought there would be just another aftermarket cheaper build plates. But when we started using them, we haven't even come across one single instance when the print came off. And I've tested to a level where I'd lift the build plates ejected off the printer onto the rack, came next day, flip it upside down, it wouldn't flip off. So we have done quite a bit of testing to make sure that doesn't happen, but we were actively working on a camera system. They would detect whether there was a fail detection or a successful ejection based on if there was anything left behind the print bed. This is the dumbest version you see, which has worked great. We'll be adding more sensors and camera system to detect if there was a fail detection to tackle that.
Thank you.
Yes, very much aware of the whole scenario that's happening in China and patent-wise at the moment. Initially, I really wanted to make this an open source project so everybody can get their hands on it. But soon we realized that the moment we make this open source, their company is going to take off that product and copy it and run wild with it. So what we have decided is this is the only version we're going to release as an open source version, and there are limitations to this model, what we can do with it. Enterprise model is where we're really targeting our customer base. As a project, it's great. I can sell you this, and you can buy 2, 5, and I can maintain my side job and pay my bills. If I really wanted to scale this operation, I really need to come up with a plan that can tackle that Chinese manufacturing and as well as the patenting issues. And hence, we've decided that we're going to focus more on software side of things, where universities can buy it as a package where it comes with a software integration, which would solve a bigger problem rather than just the hardware. Hardware is going to get copied one way or another. Hence, we've kind of come to terms with it. Probably we'll have a control over it for next 6 to 8 months. But if we manage to build a brand around it with a solution and not just a hardware product, then maybe we will be able to leverage it. But only time will tell. You never know. They might even make a better copy than us. So.
This is not the problem of copy. It's the problem of they make a patent and they restrict you to make your own product.
So we are filing for provisional patents in US as well as China at the moment. Getting that approved is easier part, especially in China, because what we have realized that they don't have a process in place, robust process in place like US, where they would give people opportunity to oppose these patents. In China, you pay $75 standard fee, and within 3 months, you have got the patent sorted. And even if the Chinese company really goes after it, you're gonna lose that patent war. So we've just decided we'll just deal with it when it comes to it. Hence, build a brand, focus on building a brand that really provides a solution rather than a product.
Hey, maybe slightly speculative question, given that you haven't got that many units out yet, but I guess 2 parts. One, which component do you think is going to fail first? And then follow on from that, how do you manage your revisioning of these 3D printed parts when you've got customers out in the field that might be using different revisions of the 3D printed components? And how do you provide support for that?
To answer your first question, the component that we think would fail is probably the connectors on the motors at this stage. While they move, there's a bit of a tug and pull on them. It's just a matter of sorting out better cable management on that front. Apart from that, components are standard, stock standards already proven, tested in trials, so we're not worried about that. Second question, I couldn't understand that, if you can repeat that.
Well, presumably, customers are printing their own components for this, right? And that in its own leads to variation in quality. And presumably, at a certain point, you're going to realize that you're going to release a revision of some of these designs for 3D printing, and customers can swap them out, which again leads to deviation in what is being used by your customers. Like, what sort of support, I guess, do you give on these kinds of things, and how do you manage the fact that there's going to be such a huge variance in what people are using?
So the reason behind releasing a kit set with printed parts is that we can offload the warranty and support onto the users themselves at this stage. So we are banking on the community to rally behind this, make their own variations of this, and also troubleshoot as they go, which has been a proven concept in 3D printing for over the last 10 years. When we release the actual enterprise model, which will come with all the machine parts and 0 3D printed parts, at that point we'll have the enterprise support built in with that product itself. For a kit set, we've decided we'll help with them on Discord channels as much as we can, but most likely it's going to come from watching YouTube videos and people helping people.
If it's the same file, you can put it on loop, but if you got students sending you at 2 a.m. a new file and you're queuing that onto your printer, how are you managing that?
Right now, it cannot just only take loop, but you can basically put the file names into the queuing system. We have gotten to a stage where I would manually put the file name into the queue. We haven't gone to a stage where a student can automatically line up those queues. That is where we want to get to, and hopefully next 6 to 8 months we'll get to that point. But queuing otherwise works seamlessly with AutoEngine script that we have made.
Thanks.
If you've got prints of different sizes, how do you make sure that when you slot them onto the shelf after printing that they don't impact each other?
So each slot on them is about 50 millimeters increments. So you can put 6 of them right now. But imagine that the print was 100 mil and you're storing in the slot 3. What it would do is it would basically skip the next slot and make sure that it keeps the number 5 slot empty and not utilize it and go into number 6 slot instead. So you can have various size of it and you can block the slots out. Right now, it's a manual process. When you set up the queue, you got to tell that, hey, my print size is 100 mil, so make sure you don't use that. And if you made a mistake, it's going to collide. But we're going to build sensors and system in place so that it doesn't happen. It can detect that there's a larger bill print into this, so let's not utilize that slot.
Do you plan to build in a system where it detects a failed printing and reinitiates the same printing?
Failed printing is, the AI detection system right now is built into Bamboo Labs and as well as Octoprint that offers onto the offers for other market solutions. We are leaving that onto the printer at this stage because it requires active monitoring of the print itself using a camera. That uses a lot of bandwidth, so we are staying away from that aspect. Your printer can detect that for you, but if it has detected that a print has failed, at that point you can tell the automation system, auto eject system, hey, it failed, just eject it and restart the print. Yes, we can do that.
Hi, do you have a version plan in the future that takes out all the parts and puts them together, or do I still have to do that?
Sorry, what is it?
Do you have a version plan in the future that puts the parts together, or do I still have to do that?
Yeah, so I've been talking to my team about this idea of instead of just having a dumb system which basically just grabs the build plate, we're planning on putting a robotic arm with different forks onto them. So imagine sometimes you want to put some magnets into your builds or bearings into your print. Then you can pause the print, use that build arm to basically go and grab the magnets, put them into it, and restart the print. Or if you just want to do something clever on the side of while you're storing the build plates, you want to resin printing is a good example of it. So what we're trialing out with printing is one process, but you're putting them into a isopropylene bath is second process, and drying it out in the third process. So this one robot would take care of all those 3 steps. So we're building a concept, we have conceptualized a system where it can do more than just ejecting a build plate. And ideally, This is what we've discussed just last week, that you might have seen the restaurant robots where it goes and grabs the empty plates and does various things. We're planning on using a similar system like a vacuum robot, but we'd have a vertical, basically a gantry on top of it with a robotic arm that can go around the whole lab and not just now eject build plate, but in the evening, as I said, I'm a very lazy person. I leave a lot of mess on the desk. All I want to do is, hey, you've got free time, just clean up my desk. So it should be able to go and grab all the components, put it on the side if need be, and if the ejection happens, goes and grab the build plates and does that at the same time. So that's the kind of automation we want to get to, but that's a distant dream, I would say.
Very cool. Final question. Are you storing the data that you're capturing anywhere? Because it's a great source of revenue.
No, not at this stage.
I would recommend it. Lots
Cool,
of people
thanks.
buying.
Thank you very much, Mikesh.
Cool, thank you very much.
Yeah, go ahead.
My name's Jack. I run a company called Robot Rampage. I recognize some faces in the room. Some of you may have been to some of our events. Some of you have built robots. Miriam, who's on your committee, built a robot in 2 days while pregnant, so anybody can do it. Is that the next one?
Yes, should be.
So a little bit about me. I'm a part-time software engineer, and I do this stuff. We started this about 3 years ago. We took a team of 7 over to BattleBots, which is on Discovery Channel, and those robots are 100 kilos, so 10 times the size of the one I've got here today. And we did pretty well. We've won the World Championship there, and we've won the Champions Tournament twice. So then we came back to New Zealand, and we thought, we want to do that here, and how can we get people doing that? So basically, we have a space in Onehunga where we have a big arena at 6 by 6 meters, and we invite people to come build robots and smash them up. I have a little example. This is a fight that happened last weekend of the robot that's here. So we had 5 Aussies come across to compete against the New Zealanders. This is an Australian robot, a New Zealand robot. So these are 13 kilogram robots, and the main aim is to just destroy each other. So they both have spinning blades. This one has a 3 kilogram blade that spins at 6,000 RPM, and the other one's a bit heavier than that, I think. So they absolutely rip each other up. Yeah, the sounds are pretty insane. Yeah, it's pretty much the fight. Oh, there we go. Yeah, so they basically tear each other up. So that's sort of what we do for fun.
How often do things go on fire?
We had 2 fires last event, and we had to evacuate everybody. So we're working on our smoke evacuation protocols at the moment. Yeah.
Lots of fire extinguishers, I take it.
Yeah, it's pretty normal. Yeah, I guess so. Basically, what is it? It's a really sort of pure mechanical design challenge, and a little bit of software and a little bit of electrical. They fight each other in a 3-minute match. If a match lasts 3 minutes, it goes to judges. Doesn't happen very often. And there's not really many rules. It's basically an open design challenge. You can build whatever you want that you think is going to destroy the other opponent the best. So that's what people really like about it. And in New Zealand, we fight 150-gram robots, which are really small, 3D printed sort of style.
The ant weight?
That's the ant weight, yeah. And then 1.3 kilogram, which we call beetle weight. So again, a lot of 3D printing, some more sort of hardcore manufacturing. And then the scale that I brought today is a 13 kilogram one, and that's sort of like our more hardcore teams who are really into it.
How heavy is your big one?
The one we take to the States is 113, so it's 10 times the size of this one. I was going to bring it today, but it's very cumbersome to move around. But if you come down to our place in Onehunga, you can see that one move around as well. Yeah, and why do it? Engineers seem to love this, as well as kids. Basically, it's got a wide range of people who are interested in it. There's a massive tension between the different parts of running these robots. So you want to you have your weight limit, you want to get as much power in there, you want it to be reliable, you want it to look cool, and they're all sort of tensions that people enjoy working with, and sort of the engineering challenge around that. And one thing I particularly like about this is this one. Everyone else is trying to do exactly the same thing as you, but better. So there's no excuses, there's no good enough. If you're not good enough, someone will do it better than you. So I like the competitive aspect of it. And also, it's sort of ever-evolving. Ideas, the materials, everything changes from year to year. It's kind of like strategy in sport. Like it's always changing, and you've always got to keep on top of things. And then if you're interested in it, you can come talk to me. But basically, we have club days that run once a month. We run the bigger robots once every 3 months. And we also have a workshop that teams can use to build. We've got a 3D printer, CNC mills, lathes, stuff like that, where you can build robots in if you want to get started. And yeah, I guess I have to do a little shill. We have a couple of upcoming events. We're hosting the first Robot Rampage World Cup in February next year. We've got teams coming from the States, Australia. We're working on Korea and the UK at the moment, so we'll see how that goes. And then we have a warm-up for the New Zealand teams in November. So if you want to grab tickets for that, it's a lot of fun. Basically all of our events, well actually all of our events have been sold out like a month before, so you have to get in quick. Yeah, so if you have any questions, come have a look at the robot after.
Awesome, thank you, Jack.
How loose are your rules when it comes to like the severity of how, how dangerous you can make your robots?
You can basically make them as dangerous as you want. We just don't allow flamethrowers because it damages our glass. But aside from that, there's pretty much any rules. Yeah, the ant weights are sort of like, it'll feel like it'll cut you. The beta weights might cut your finger off. The feather weights will feel like it'll kill you. And then the heavyweights will feel like it'll kill a whole rugby team. So that's sort of the scale of scariness, yeah.
Awesome, thank you.
So our big arena is 6 by 6 meters. So it's like steel up to 600 mil high, and then the top half is 12 mil bulletproof glass, polycarbonate. So that's what kind of like contains everything. And it's pretty scary even when it's within that arena.
My question is there any weight category for the robots, or you can just make them fight between small?
Yeah, so they normally fight within their weight category. So like the 13 kilos will fight the 13 kilos, the 1.3 will fight the 1.3, yeah.
Are they fighting autonomously or they're remote controlled?
They're all radio controlled, yeah.
Got it, thank you.
Yeah, I'm just wondering if you can actually do a swarm, like you cut your 13 kilograms into like, I don't know, 10 little robots or...
Yeah, you definitely can. The weight limit's just like an overall limit. Last weekend we had a robot that was split into 2 sort of half-weight ones, so you can take that as far as you want.
Have you ever had like the smaller robots try beat up a larger robot? Like how many small robots would it take to beat up a big robot?
The big robot, even just without its weapon, will easily destroy the smaller robots. Yeah. Yeah. Cool. Thank you so much.
Thank you, Jack. Come have a chat to Jack after. I'm sure you all have more questions.
There we go. Okay, here's some background. Yeah, electronics. I did stuff in high school, bought a 3D printer. Liam's actually here, I built it with him. Yeah, TiVo Black Widow. Weird one, learnt lots though, trying to get stuff running properly. There's a business card on the right that I made and brought last year. So,
still have it.
Yeah. Yeah, it's cool stuff. So, this is the train map of Auckland. So it shows in real time where all the trains are. So yellow is the eastern line, red southern line, green for the western. There's only Hunga, which is like light blue, and the purple is the out-of-service trains. So that's a quick rundown on it. It's got a Wi-Fi chip. I'm hotspotting it from my phone, and that's how it works. I use KiCad. It's free and open source. You can design circuit boards too. It's really good, especially version 9 that came out just before I did this project. It's awesome. Yeah, making your own circuit boards is cheaper and easier than you might think. ESP32C3, so this is the weird new RISC-V one. So, bit technical. It's like ARM, but it's open source. So it's an open source set of instructions for the CPU on this. Bit technical, quite cool. Lots of fun and costs, yeah, about $1.50 US, and it's amazing. So I made this project a lot harder than it needed to be. I used an ESP32 chip. It's this little black thing here, 5 by 5 millimeters. And I had to put the crystal, I had to organize all the capacitors, do the antenna matching, do 50 ohms impedance. It's a lot of work. Oh, it's a lot of work. You don't have to. You can use an ESP32 module. It's got everything you need, basically. It's got the crystal, got the chip, got the flash, got the antenna, all there. Makes stuff a lot easier. So, some of the manufacturing stuff. So, I've now sold 80 of these. I didn't expect to do that, but I'm not complaining.
Order yet?
I just put in my 5th order.
Your 5th? Oh.
Yeah.
I've progressed since
So,
we last talked
yeah,
about it.
KiCad plugins make manufacturing a lot easier. So I use JAWS PCB because they're the cheapest. because I don't want to solder all these LEDs by hand. It'd be a nightmare. Yeah, I've done it for 8 of them, and it took me an hour. Yeah, KeyKit. It's a plugin for KiCad. It panelizes stuff. So that's where you've got 3 circuit boards in a panel. Makes stuff a lot cheaper. It's lots of fun. Jealousy PCB Tools. So that's another open source plugin that generates all the manufacturing data. So that's the BOM and the CPL. So that's the XY position and rotation of components. Really helpful. So I could basically just press one button and get all the manufacturing data for assembling and all the circuit boards. I also maintain a Jealousy PCB component library. So that's got all the standard components, about 1,500 of them. Makes my life a lot easier. It means I get stock pricing and I can just press go and not have to look for all the components and get all the footprints. Makes that a lot easier. So some of the cool stuff on this making it easier. Some of these things have been going to like elderly people, so I wanted to make firmware updates, okay, well, somewhat easy. This has native USB on it, so this is the cool thing with the C3 version of the ESP32. It has native USB support. I use a cool open source project called ESP Web Tools. So it's a Chrome tab in your browser, sends serial over the USB-C connector to the ESP32. So it sends serial, which is the Wi-Fi name and password. So you don't need anything. You just go to a web page, plug this in, and you can set it up with your Wi-Fi network. Makes it a lot easier. You can also do firmware updates over serial with this chip. Makes stuff a lot easier. Also wrote some dodgy code so that when I do a commit to the Git repository with the firmware and code, it automatically updates that website. So I can just make a single commit on my computer, it updates the website, people can install the firmware in 30 seconds. Platform IO and VS Code, really helpful. Open source. This is all open source on GitHub. You can look at all the files. You don't even need to pay for circuit board software. You can just look at how badly I designed things. Or how well I designed things, who knows. If you're doing this, lots of circuit stuff with KiCad's open source now. Don't make the same mistakes other people do. Learn from stuff. It's all open and it's really helpful. Oh, and there's the live stream. So if you're curious, this is the other cool thing with open source. There are now 2 projects that are basing off the work that I've done. So there's one for Helsinki and there's one for Prague that are in the works. And I'm helping them out a little bit. So that's lots of fun. Future plans. Wellington has been ordered. That's Wellington over there. More difficult than I thought it was going to be, but it's getting there. Future stuff, mini departure display, like showing which stuff is leaving from like a bus stop or a train station. Maybe doing Melbourne, a lot of work, but I might do it. ESP32 bus pirate. Don't really have details go into it. It's a cool stuff for looking at serial and weird connections and looking at it. Anyway, that's it.
Awesome. Cool, thank you.
Wellington's already open source on GitHub if you want to have a look at stuff.
Do you get your train data just from like AT? Is it just...
Yeah, it's free and available to everyone. You have to pay access, but they give it out to everyone. It's got all the trains, buses, and ferries. It's about 2 megabytes worth of data every 20 seconds.
Have you thought about expanding it to bus networks and ferries?
I have. Liam, who's actually here today, really wants me to do bus 70. I don't think I'd sell enough of them for it to make sense, but I might be able to be convinced. I'm not sure.
All right, thank you.
If anyone here has heard of Driving Creek Railway, it's the best railway in all of New Zealand, and I would love you to make a map of that.
How many iterations did it take for the PCB to be correct? And the KiCad, how accessible is it to software engineers who may have had some electronics training?
So the KiCad library can be installed through the KiCad plugin manager. It's about 30 seconds to install it, and it's automatically then when you make it schematic. It just has the prefix of PCM before it. The format that KiCad stuff in is weird. It's a very unusual format. I basically wrote, it's basically just text. It's S parameter. It's weird. It's basically only KiCad uses at this point. It's really annoying to deal with KiCad's file formats, but there are libraries to deal with it, but some of them are out of date. It's a whole mess. But you can work with it if you want to, but it's a bit of a learning curve.
Awesome, cool. Thank you so much, Chris.
Okay, my first FPGA. Now, this subtitle is producing AHD from an ESP32, which That's a bit hard to parse, but hopefully you'll understand by the end of my very quick talk. I made too many slides, so I'm going to have to try and get through them quickly.
We have a timer there, so it's
yeah,
okay.
great. So who am I? I went to Auckland Uni, did a computer science degree. I founded a DJ software company that was incredibly successful, and then I founded an EV charging network, which is still successful but not yet profitable. I think that goes for every EV charging network in the world right now. The project I've been working on is my lovely wife is a fan of East Germany. Well, Germany in general, but more specifically East Germany. And this is the Trabant, which was the kind of people's car of East Germany, made for many, many decades. And I decided as a present for her, I would buy one, import it to New Zealand, and then convert it to electric. So the first two parts are done. There it is sitting in my driveway. But converting it to electric, that's a challenge. That's a whole nother tale for another day. But as part of that process, I wanted to be able to add some information display, a human-machine interface to the car. And I thought, well, also, it'd be great to add a reversing camera. And when I looked into reversing cameras on AliExpress, these days, they come in high definition somehow. And it turns out that that's because there's an analog high definition standard. And I don't mean component video, I mean using like a single coax cable. And that's amazing and cool. And I thought, well, can I use the same display? Those monitors that they sell you have two inputs, one for the reversing camera and a second one which you can display anything you want on. And I wanted to use an ESP32. You've heard from Chris how fantastic ESP32s are, but they don't output really video in any particular format at all. You can, however, you can trick them into producing VGA or something like VGA. There's some open source libraries that let you do it, but they really hammer on the DMA subsystem of the device because they have quite high dot clocks. They're having to output data very quickly. Analog HD, on the other hand, is an analog signal, and it's supposedly described as open, but I have yet to find any disclosure anywhere on the internet about how it actually works. So I had to just reverse engineer it. And so that was part of this process. So the first idea I had was like, okay, well, I've got a VGA signal coming out of my ESP32. I could not find a direct converter, but I could convert it to HDMI, and then I could convert the HDMI to analog HD. But that's horrible. It just made me feel icky inside, and I'm sure it would also be unreliable having these things rattling around inside the dashboard of a vehicle. So my next idea was I did some more extensive searching, and I did find an off-the-shelf PCB that would do the conversion in a single step. However, it turned out that what they were doing was converting it to HDMI and then converting that to analog HD, which continued to make me feel disgusting. And it had the same challenge as any of the solutions that started from a VGA signal, which is that it's hard to produce a high-resolution VGA signal directly from an ESP32 because of the dot clock frequency. So I thought, well, I think I can do it myself. And by doing so, I could then produce the data at a lower rate because the analog HD video is only actually running at 25 hertz, which is perfectly adequate for my information display and makes it easier for the ESP32 to output the data. But it's, there's some challenges there, right? I've got to somehow produce an 11.5 megahertz subcarrier, and it's an analog signal, and even the ESP32 doesn't really output analog. You've got to, some of the models do, but the more modern ones don't, and even the ones that do certainly can't produce anything at that sort of frequency. So there'd have to be some sort of external conversion stage anyway to get it to analog. What is analog HD? I don't need to go into any real detail. If you know anything at all about PAL or NTSC, it's like that, but overclocked. So like HDTV, but in the analog domain. So, yeah, see, the minutes go by so quickly. And this is where I landed. I decided I wanted to use an FPGA. Now, the crazy thing about that is I've never used an FPGA before in my life. I've never programmed one. I don't really know how they work, but I knew that they were capable of dealing with very high frequency signals, digital signals. And this just happened to be the cheapest one I could find on AliExpress, all of $15 shipped to New Zealand. And it's actually a complete dev kit. It's not just the FPGA itself. It's got all the support circuitry, the USB bus, and some nice IOs on there. How do you program an FPGA? You use a language that's, I don't have time to describe exactly what an FPGA is, but it's programmable hardware, and we're here at a hardware meetup, so that should resonate with you. But you program it with these languages that are really not languages at all, because they don't have loops or anything. They're more of a concise way of describing a circuit topology and a sequence of logic steps. And there's all sorts of subtlety to that, because all of those logical elements are operating in parallel, and you have to go out of your way to make them not in parallel, to sequence them and synchronize them to clocks, and it's, there's a lot of depth and complexity to that. Another big challenge, I wanted an analog signal, but FPGAs are inherently digital. But luckily, the particular FPGA that I'd ordered had an adjustable duty cycle on the clock generator. So I was able to adjust that cycle by cycle, and as if it was a PWM, and filter it back into an analog signal, which actually worked. Another problem was that the PLL generator on board, it had nothing like the frequency resolution I needed, but I was able to write, that is the literal code, I screenshotted that generates the precise frequency that I needed. Another challenge, I was only really working at 12 times the frequency that I wanted to generate, so that still leaves a lot of the PWM residue. However, I was able to accomplish another hack, which was to add a second copy of the PWM signal delayed by half a cycle, and then average the two together. And you can sort of see, I've visualized the effect that has. It reduces the amplitude of the actual PWM component, and it doubles the frequency. So you end up with a quarter of the residual distortion. And it worked. That's it. That's the final circuit, and that's just a test signal, but it proved that it worked, and I was very happy. It took me about 3 weeks, beginning to end. I was thrilled to get it done, and very proud, and so I wanted to share it with you guys.
Is your wife happy now?
She's happy that I'm happy. She'll be more happy when the car is.
What do you plan with the car's combustible parts? It's a flammable car. we had two at home. I know they are really, really weak to any external and internal stimuli.
Yeah, it's not going to be a daily driver, that's for sure. It's going to be more of a show car than anything. Yeah.
So all of this looks to be born out of your determination to use coax. You wanted to use that particular model to display stuff, right?
That's right.
You really set yourself up for some challenges in doing that. Was there ever a point through this that you were ready to look for different displays?
No, actually, it progressed quite smoothly, and there was a lot of luck involved. The fact that the cheapest FPGA kit I could get off AliExpress just happened to have these very, very useful features and it was a challenge. It's like solving a puzzle, and I really enjoyed that about it. In my spare time, I'm a demo coder for the Commodore 64. It's a similarly challenging hobby.
Are you going to open source all your findings with this to actually make the standard open for everyone to use?
Oh yeah, that's a great idea, and I would love to. I need to find a mechanism to do that. I don't know where I would do that publishing, so please make suggestions. GitHub. Okay, but there's not. Sure. All right.
Thank you so much, Steve. That was such a cool project.
Mark, it's a device that I was trying to do like 7 years ago with a friend, but being poor is not fun in Mexico, so I stopped doing it. But now that I'm here, it's again restarting it. So this is a little bit of introduction.
Oh, introduce your name.
Ah, true. My name is Alberto. I work here, so you already know me. I come from Mexico, and you know that we have really nice beers. And it's actually this probably what it is. And my mom always telling me, oh, you will never get anything from being an alcoholic, but actually I get something. Oh, sorry. Oh. For some reason, I ended up doing a master's degree in Italy about biomedical engineering, nothing related to this. But it was found that there is one of the best wines, and I didn't like it. And I ended up doing a project about beers. And I actually ended up being more alcoholic for beers in Italy. Yeah, that's the university. It's the Politecnico di Milano, pretty good university. And now I'm here because I was doing a PhD in robotics, again, totally unrelated, but science. And this is the real event that triggered our project. That place, if you have the time to go to Milan, is the best place in Milan. Forget about the Duomo, forget about the Last Supper. That place is the place that you need to visit. It's Birrificio Lambrate. They are not sponsoring me. I would love it, but they are not. Oh, shit, I used this presentation for another time, so I have another clock. That place sells handcraft beer, best handcraft beer in Italy, whole Italy. And I was every single night, every single Friday there with a friend drinking. And one day, it's like, oh, you know that actually handcraft beer works similar to the wine. You cannot drink, I don't know, like a stout at 4 degrees. We drink like beers at 4 degrees because they are shit. The lagers are really bitter. So that's why we try to, like, how do you say this? Sorry, my English is not working anymore right now. Yeah, you try to blend this flavor of the lager with the cold temperature, so it's just fresh. But as the wines, when you are drinking a more robust beer, you want to detect those flavors. And in order to detect those flavors, you need to drink it warmer. It's not the same. Like you see, here you can see different type of beers, and if it's darker, you need to consume it like a higher temperature. And that's the problem one that we try to solve. And the problem two is that, again, you are drinking, you have your beers, you get it from the supermarket. Time to time, they are not cold at all, so you need to put it on the freezer. And you are having the barbecue with your friends, and what happened? They die. So the idea is to make a smart thermometer for beers, like let you know when your beer is a perfect temperature. 7 years ago, we did this research, and I did that research like 2 weeks ago. Then this is when I wake up and say, I need to restart this thing. And I found the same solution, that is this. You can put it into your bottle of wine, but there is not actually a way to know when the beer or the wine is ready, because you still need to go to the fridge and open it, closing it. So there is no point of having that. It's the same like you go and touch it with your hand.
I'm really good at forgetting it in the freezer and then discovering it later.
And again, it was 7 years ago, like smart things were not a thing, and that's what we think. Oh, we need to connect our beer to our cell phones. Smart. And that's actually what happened. You can see in another areas, they're already doing it, like the meat. It's kind of the same principle. You have some app, you have a thermometer, you put it in your meat, you forget about it, and at some point, you know that it's cooked. So that was our idea. Mark, it's a sensor, connect your Bluetooth to your cell phone. Some renders that we made, again, 7 years ago, quite old. And yeah, if you're wondering, yeah, there is a prototype, but it's in my bag. We did this like 7 years ago, so the electronics probably needs to be improved. Like, this is just like the first BLE model that comes to the market, that it was from Nordic. not know if the standard is still okay because it's 4.0, and right now we're at least in the 5.0 that gives you better advantages. So I need to rethink on the electronics and everything, that's the next step. And all this was triggered because I will start to work here, I have a stable job, I can eat, finally.
Woohoo!
And I can restart my projects. And the last thing is like, anyone to share a beer with me? Feel free. I can be your lab rat, you can be my lab rat, I don't know how this is gonna work, but feel free.
So you're basically about to start picking this up again to give it another go. Awesome, cool, cool. Do you need any help from anyone? Yeah.
I feel free again, like if you want to bring a beer, if you want to help with code, anything, it's free. Well, I don't have money to pay you guys.
Passion project, passion for beer. Yeah.
Passion for beer, that's it. Passione avanti.
I know refrigerators are not made the same way as before, but are they not shading the connection between your beer and your phone? Like if you are not in the kitchen, not next to the fridge, is not blocking the information?
Well, actually, Bluetooth BLE is quite good. For sure, you will not be in a different building, but BLE can handle hundreds of meters. So it's still it's not planned to be really far from you, but in the same area that you are, in your own house, for sure it's gonna work.
But the freezer is metal. Does it screen in the signal?
Not really. I have tried it, and I was reaching, 50 meters. That it's good, and it was a really old prototype. The new technologies actually are better in that sense.
Did you try to put your mobile phone, play in your earbuds some music into the fridge and listen to the music?
That one, not really. That's probably a good test to do in the future.
Yeah, you should try it first because maybe the signal will be totally lost from the fridge because it's metal. It's like a Faraday cell.
Yeah, in that sense, also not that much signal per se. For example, if you have music, it's also a trade-off with the Bluetooth because we actually compress a lot the music. Or for example, for medical devices, it was also not good, the 4.0, because of the quantity of data that the BLE can pass. But again, BLE 5.0 address that problem and increase the baud rate, the kind of data that you can transmit. And again, I didn't do it in that time because even when I started this project, headphones with Bluetooth were not a thing. And it was only my sensor in the fridge, and I walking around my house, and it was working.
Awesome. Cool. Thank you very much.
Yeah.
So the original motivation for this was annoyance, in that I had an existing home alarm, and it was basically 1990s technology, except for the bits that were from the 1970s, even though it's a current model that's sold now. It had this daughter board that added barely to their internet functionality. The app looked like it was created by an intern using an app construction kit. And the final straw was when they said that from now on you have to pay a monthly fee to use this collection of bugs. And I thought, you've got to be able to do better than that. So that was the starting point, just the existing panel. There are 12 sensors. Each of those cables has 4 wires in it. So it's basically 48 connections running into the thing. I partly disassembled it at that point. So basically cleared the thing out. And I thought an alarm is basically just a PLC with very fixed functionality and not a Siemens or something like that. But this is just a cheap $40 AliExpress PLC. So that's an ESP32, since that seems to be a theme for the evening. And then just an I2C expander, so IO expanders, so 16 inputs, 16 outputs. So effectively that is an alarm controller, just you need to do a bit of programming on it. So that's the existing alarm panel, alarm enclosure, everything cleared out. We did have the PLC put in there. The main problem with this, I've mentioned the 48 wires going into this, so you need a massive amount of fan out. So there are these connectors called Wago connectors, which are sprinkler connectors for mains connections, made in Germany. And these are Chinese clones, so I would never put 240 volts through them, but you can certainly put 12 volts through them. And they've got a fan out of, in this case, I think it's 3 to 12. So basically you've got all the inputs going into these spring clip connectors rather than having to run them into the board. That's a complete thing set up, so switch mode power supply, the PLC, the input connectors, and there's some optocoupler input relay, which I'll explain in a second. So that was, if you remember the original alarm photo, that's the replacement, and that's all stuff off AliExpress. And as I said, it's about $40, and the rest of the parts are maybe 20 or something like that. And that's the thing back on the wall just before I wired up all the cables to go into it. So I also needed a keypad. So again, AliExpress, $20. This is more than just a keypad. It does NFC, so you can tap your phone against it to disarm the alarm. It also does 125 kilohertz and 13.56 megahertz RFID. So if you want to let the neighbours in to feed the cats, you give them one of these RFID tags, and they can come in and disarm the alarm that way. The one problem with this is that all the alarm connections are 4 wires, 12 volts ground and 2 wires for signalling. This thing needs a lot more than just 2 wires, so there's a bit of trickery involved in order to send the signalling off this thing over the remaining 2 wires, which is why I've got that optocoupler relay board in there to be able to do the signalling over the remaining 2 wires. Just setting it up to test. Because one of the things is this is a very long link going back to the alarm, and I was worried about voltage drop across the thing, so I tested the whole thing. And that was the complete keypad on the wall. That's basically a wall patched up $20 keypad. And with Home Assistant, that's the remaining thing. There's really not much to show. So because this is a PLC, you could in theory do the complete alarm using ladder logic on the PLC. And I got about halfway through that and I thought, bugger this, I'll just do it with Alarmo. So Alarmo takes care of everything else, so you don't need to worry about it. The output of the board is MQTT, so it just integrates directly into Home Assistant. And that's it. I've done a bunch of blog posts on it, which gives a lot more detail about wiring and what you need to get and so on and so forth. If anyone else wants to do one of these super cheap alarms.
Yeah, I share your frustration regarding the alarm systems from the 70s. And so I'd like to do what you did. I'm just wondering, a stupid question, but what about insurance? Like, what happens if your house burns down because something went wrong and that's one of the fears I had, and I'm wondering if you thought about that.
It's binary. So when you fill out the insurance form, they say, do you have an alarm? And if you say yes, then you have an alarm, and that lowers your premiums. For commercial buildings, you will need to get a rated, certified, approved alarm. But you see people putting in these silly little Wi-Fi alarms, which is just like a speaker and a door sensor. And for insurance purposes, that seems to be enough to qualify as an alarm.
Excellent, thanks.
Hi. I'm using the exact same board to control my underfloor heating. I'm using ESP Home, which I've been enjoying learning about over the last couple of months.
So one thing with that is there's 2 lots of firmware for that. You can either do it in ESP Home, which means you've got to muck around with a lot of the ESP stuff. They've also got their own firmware, which is a purely web-based interface, which is really nice. You just go up to the web page, you say, I want these sensors on, I want these things off. And then, for example, if you're doing a walk-around test for the sensors to see that they're being triggered, then there's a web page which flashes all the lights on each sensor as you're walking past it. So I found it much easier to just use the built-in firmware in the web interface.
It never even occurred to me to look if there was a web interface on it. I put ESP Home on it without checking.
Right, yeah. I mean, I tried ESP Home and I thought it's just a lot of YAML and a lot of mucking around. It was much easier to just use the web interface.
Sorry, just when you were saying the RFID frequencies, to confirm you can scan your cat, is what you said? Your cat RFID tag, the chip in it.
No, it was to feed a cat. I said,
okay.
if you want to let the neighbours in to feed the cat,
I was curious if you said it was the cat tag, and I'm like,
no.
I guess if you got that frequency, you could.
No, just a little plastic fob thing.
Just hold it up.
Yeah, I'm Michael. I'm building a boat. Yeah, it's just to be clear, it's unmanned, autonomous, and yeah, the goal is just to have a boat that can go anywhere on the ocean. Why am I doing it is a question I find very hard to answer. Bit of a design exercise, just combining, I guess, various engineering experience I've got into one project. Solo crossings. I really like the idea, or the little journeys people go on when someone tries to kayak from New Zealand to Australia, or like South America to Australia, and then they get swirled around in cyclones or whatever and diverted for months at a time. Sometimes when I go to the beach and I'm looking, west, I just think like, I'd like to just keep paddling, but also I don't want to die that way, or spend 4 months getting blisters everywhere. So yeah, this boat is going to do that on my behalf, in theory. Yeah, this is just a sequence of progressively less likely to succeed journeys. So far I've done Lake Papuki with a boogie board and this motor. Next is Rangitoto, should be able to do that in 8 hours. Then next Little Barrier, next North Island. So these are all within mobile, like 4G reception. And just like one design parameter I'll give you is aiming for like 1 meter per second average speed, like sustained. So walking pace. Yeah, if I can get around the North Island, then I want to do some missions which will rely on satellite internet for control. So Auckland to Sydney is the same distance as doing a lap of the North Island. Last time I went to Sydney, I remember just going to the beach and just like, yep, pointless, I know, but still want to do it. And then the ultimate goal is to get around the world, which is actually just around Antarctica. And at that point, it's going to be a 6-month trip. And I don't know if you can see, I just put some photos of biofouling on a project I worked on. I don't know if you can see like the corals and things growing inside that box. They all grew in 6 months. So yeah, if I can keep it moving. That's the boat, 3 meters long, trying to build in redundancy. So it's got a rigid sail, 2 motors, hopefully 2 sets of electronics, etc., 2 solar arrays. And yeah, if the sail snaps off, hopefully the solar is enough, and vice versa. Yeah, this is the hubless azimuth thruster. Main idea of that is to not get caught on like weed or ropes. So a lot of props, the times I've been on boats and they drive through a rope or whatever, just instantly gets tightly wound onto a shaft, and I'm not going to be there to unwind it or dive under and try and cut it off. So this thing seems to be able to at least reverse and backflush. There's a little picture of a similar hubless prop just snaking a bit of rope through effortlessly. And yeah, so it's got a drive shaft, but also it swivels. So hopefully the boat will be able to do things like position hold fairly easily. Yeah.
Cool.
Yeah, it was surprisingly, even though I just eyeballed the prop design, it was not terribly inefficient. Yeah, progress, built a motor, put it in the lake, drove it through a bunch of weeds, reversed it, and it spits most of the weeds out of them pretty easily. Next step, the Rangitoto mission, I'll just need to order some stuff off AliExpress and put it in a ROV tube, make it like submersible. And yeah, there's just some specs, if you like specs.
When are you planning on doing your next one?
The next mission?
Yes.
Not yet. I'll give you a date, but it's like definitely. Let's say before the end of the year.
Oh, cool,
Yeah.
cool, awesome. Well, you'll have to come and tell us all about it when you've done it.
Thanks.
Cool. Awesome, thank you so much.
I guess 2-part question. First, one of the biggest challenges as a hobbyist is designing good detailed mechanical designing. Your design looks quite good. What software do you use, or are you using some from work? And then second question, you working alone or have you got anyone else involved?
Yeah, so second question, yeah, it's a solo project. I guess that's like tied to the solo like crossing vibe. Yeah, and the CAD software is SolidWorks. That's expensive software. I wouldn't recommend to anyone, but I've just got years of experience. I'd recommend using Onshape if you want something probably better and free for hobbyists. Yeah.
Your solar power recharging, what happens if the sky clouds up while you're halfway across the Tasman Sea? Does the boat just stop, or?
Yeah, so I guess even if I was just reliant on sail power,
Yep.
So it's got, what is it, like 40 amp hours of battery. I think the Raspberry Pi control system use something like 5 watts, and I think you can get 500 watt hours a day in summer. So what is that, 100 hours until it goes flat?
So you'd have to be pretty unlucky.
Yeah, I think avoid doing it in winter.
Yeah, gotcha.
And just make sure it can boot up again once it's completely flat.
And what will happen on strong winds? How you deform the sail or reduce area?
My design principle for that is as strong as a surfboard. Like you can throw a surfboard into an ocean break and usually they don't snap. That mast looks like it's going to snap, which I need to sort out. But like I want to be able to put this into a surf break, and then when it's dumped on by like a 16 meter. Hopefully it will survive.
Have you thought of adding any long range communication system? Here, sorry, this way.
Sorry, I've got it.
Yeah, here.
I know,
Over here.
like
This way, here.
Oh, okay, sweet.
Yeah. So yeah, LoRaWAN or LoRa technology for the communication, or you're just mainly relying on 4G or maybe satellite?
Yeah. So 4G, pretty happy that it's got range up to 60 k's offshore for almost all of New Zealand. And further than that, it will be Starlink if it doesn't block me for just migrating across the ocean. And as a fallback, like Iridium satellite. So Iridium will just be very short commands, like what are your coordinates, and like go to this next waypoint coordinate.
I got a question around, I don't know too much about sailing wise, but what made you decide on a single hull as opposed to like a dual hull catamaran kind of thing to prevent potential capsizing?
Yeah,
things like that.
I think I just am trying to assume as many things will go wrong with it, and like it will end up upside down, whether it's a catamaran or not. Like just ocean storm waves are going to turn anything upside down, I assume, and so it's just designed to be easily self-righting. I think a catamaran would make that a bit harder.
Good point. Yep.
But I might try and put an outrigger on it, maybe.
Is there any redundancy plan for not being mistaken as a drug dealing vessel or spy boat?
I put a high-vis, a small bit of high-vis, so like hopefully you won't see it most of the time, but if you get close enough, you go, oh, it's probably not.
Isn't it if you wear a high-vis, you can get in anywhere, right? So cross any water you want. Awesome. Sweet. Thank you so much, Mike.
Thank you.
So yeah, my project is an incredibly stupid web app. If you click, click begin ritual.
I'm quite worried.
So yeah, this is obviously doing not much, but the back end and the story behind it is kind of the arguably interesting part of the project. So for context, I'm a patent attorney, and I registered in at the start of 2023, roughly, so a couple of years ago. But when I registered, the main question on my mind was, do I have the longest name on the patent attorney register? And there's about 1,500 between Australia and New Zealand. So obviously I hopped on Chrome DevTools and tried to scrape the entire register and then rank everyone. And I did have the longest name at the time.
Really?
Yeah. So I was very proud of myself because my full name's Louis Francisco Yates Haberfield Short. So, there wasn't a whole lot of competition. And then, so I basically built this scraping tool, and then I was like, well, I've got all this data that I'm scraping all the time to check that I still have the longest name. So I might as well figure out who's newly registered and who's moving firms and all of that. So I was basically stalking everyone on the register to figure out so I could tell everyone, all my colleagues, I could go, hey, I know who's registered, and I could go, oh, this person moved between firms and stuff like that. And eventually, I watched June 2 in the start of 2024, and I was like, well, yeah, that's kind of where the throat singing thing came from, because there's a bit at the start of the movie where they kind of display a bit of a quote, and then it fades out, and there's some throat singing. And I was like, it'd be really funny if I showed the newly registered patent attorneys and did throat singing for them. So if you click this button and there is a newly registered patent attorney within the last week, it'll do some throat singing for them. And it's really, my favorite thing to do is comment on people's LinkedIn posts when they register and then just send them a link to the website. And then they'll kind of go, well, I don't know whether they look at it or not, but I like to think that they kind of go, what the fuck is this?
By the way, I've known Louis for 8 years, and this is probably not the weirdest project he's made, by the way.
Oh, yeah, this is pretty tame. Actually, let me...
Oh, it logged you out.
Yeah, so there are other tabs. So this one is the actual... That one does the actual name ranking. So as you can see, someone's actually overtaken me in November, which was very sad. But yeah, there I am in number 2. It only goes through 10 of them. Not all 1,500, thankfully.
Again, this is not the weirdest project he's made.
But yeah, there's also like a thing for you can see who's moved between firms and who's left the register as well. But yeah, so at one point I actually, before I had turned this into a web, the reason this is a web app is because it was originally on a Raspberry Pi that I kind of snuck into the office and like hid in a document storage like room. So I bought a monitor off Trade Me and came in at like 9 p.m. into the office and just like hid it in there. And I would sort of do it every day so I could go like show people. And then we moved floors and I had to put it under my desk. And I was warned against trying to figure out a way to SSH into it from home. But yeah, I was living on a Raspberry Pi for a while, but then I got a new job. And so I was like, oh, but how are my colleagues that are about to get registered going to know and get throat singing done for them? So I better turn it into a web app. So that was like what I did when I changed jobs. And yeah, now the people at my old firm can go and check whether they have been registered or not, which, yeah, you'd hope they would know. But yeah, so that's pretty much it.
Hey, awesome project. Do you have a public list of all your projects that you've done in a simple vein that we can go check out?
It's not, a lot of them might not make a lot of sense from just like looking at the repository. Well, yeah, the actual hardware ones were, while I was at uni, we had like a minion thing. Well, actually, we were doing a computer vision project, and I was like, rather than actually doing the project, I'm gonna like get a Despicable Me minion plushie and then put a camera inside of it, and then like put a classifier on it to recognize bananas. And then I kind of added like jumper wires into its nipples as well and like turned it into a voltmeter. And so it would kind of like so it would measure the voltage and then like make noises proportional to the voltage, like kind of pain noises or whatever. But also recognize bananas and kind of go banana. And then conveniently there was a Stein, I think, or like it was an engineering bar crawl, which was minion themed. So I could take my plushie around and like there were bananas everywhere. So it was very noisy, so you couldn't really hear it. But yeah.
I think we need a list of these projects and where we could check them out and
a
portfolio of your projects.
Basically on my GitHub, I guess, but it's not very organized. And I don't really make any blog posts or anything, so you just have to talk to me, I guess.
You just need to become an influencer, I reckon.
Oh, yeah.
Cool.
Make YouTube videos.
Any last questions? No. I think they're all just confused.
Yeah. Good.
That's what you're here for. Awesome. Thank you, Louis.
Okay.
Hello. I'm Adrian. I guess a bit of personal history. I have previously been a lecturer at Waikato University. I taught physics and electronics and optics. And I have started a few companies. Perhaps I'm a serial entrepreneur, I don't know. But this is, well, yeah, just a small project. It's designed to connect to burglar alarms, and thank you for the primer on burglar alarms earlier. That was helpful. And historically, burglar alarms would communicate events to a central monitoring station using the old landline, the old copper line. And that's the POTS, the plain old telephone service, if you don't know what POTS is. But then, of course, they started getting replaced with optical fibers and fiber internet, so there was a need for an adapter to convert from the old phone system to an internet reporting. And a lot of companies made these, and they made them with Ethernet connections because they wanted them to be reliable, but that was a bit of a pain. So we thought we'd make one with Wi-Fi, but Wi-Fi is potentially unreliable because people can just change their router and change their password and things. So also added a I2 LoRa connection as a backup connection. So that's kind of the motivation. Inside is a ESP module, ESP32 again.
Crazy.
And a LoRa module and some custom electronics to simulate a phone line and a relay output and some 12 volts inputs. The all of the audio processing is done on the ESP32, so the ADC and the DAC are just connected to the phone line simulator with digital I/O to say whether it's on hook or off hook, and again I/O for the inputs and outputs. So that's just connected to the burglar alarm, its analog phone line, its key switch, which I'll come to in a moment, and possibly some status controls can go back the other way. You saw the picture before, but it looks like that. So the way it works, if we arm the alarm, then the alarm picks up the phone, the ESP presents a dial tone, some number is dialed, and then a handshake is sent, and then the event code is sent. It goes to the central monitoring station, which is on the left here showing, and then when it's acknowledged from the central monitoring station, then it's acknowledged back to the alarm. So this lets you listen to the alarm. So that was on Wi-Fi, this is on LoRa. So yeah, that's its operation, and eventually the event turns up at the monitoring station. Sorry for the aliasing on the screen, that's just a camera pointed towards the screen. So that relay we mentioned before is useful for things like this.
Arm the alarm system.
So that's just using the relay on the module to connect to the key switch, which can arm and disarm the alarm. So that's pretty much it. I kept it short, but you may have noticed the dates on the previous screen. Another project's at 7 years old. I'm glad I'm not the only one. And it smells suspiciously commercial, doesn't it? Well, we did have a cornerstone customer, a monitoring station in Christchurch, but they got acquired by a larger company, and the larger company weren't interested in new developments, so it kind of stopped. Which means that I have hardware collecting dust. So if you want to connect the POTS thing to a Wi-Fi or a LoRa thing, then come and talk to me, because maybe I can be of help. Not very far, to be honest. I did, it's a while ago, I'm trying to remember. I tried 2 testing with the LoRa between units, and that worked well if one of the units was really high, but otherwise the sort of the ground effect was a problem and shortened the range. But we did also use it with a service, and I forget the name of it, that I think was provided by Spark at the time, and that worked just fine as well.
Thank you so much, Adrian. Cheers.
Okay, I'm Ralph. One of my hobbies is 3D printing polyhedron, so I just brought in a few pieces to show.
Can you come over here so that the camera can see it?
Oh, okay. So maybe quickly pass it around. So I've got 3, so I'll send them down 3 different routes.
Are they like disassembleable?
Yep. So they're 3D printed in parts and then assembled. The big reason for printing them in parts is that I don't have a multicolour printer, so I have to do each colour separately. But the other reason is that you end up with a better surface finish, because the surface finish you get depends on sort of the angle of the plane. And if you print it in parts, then you can choose the angle to optimise the surface quality. So most of those are printed the outside surface downwards. And then when you assemble them, of course, you get all the nice smooth surface on the inside and the rougher surfaces. So the smooth surfaces on the outside and the rougher surfaces on the inside. So they're not glued together. They're held together under compression by rubber bands. So when I first started doing them, I tried gluing them, but fairly obviously what happens is any little misalignment as you glue individual pieces together all adds up, and then you get to the last piece and it doesn't fit. Whereas with the rubber band holding it under compression, basically it ends up self-aligning. Sort of everything's under equal pressure, so it ends up sort of an equal distance from the centre. And then just to keep all the parts in the right position, there's alignment holes on the interior faces, and I use struts, which are just short pieces of 3D printing filament to hold everything together.
Awesome.
Yep. If you gently tease them apart a bit, you'll actually see those struts inside. Yeah, okay?
Sweet. What do you call them?
Polyhedra.
Polyhedras.
How long did it take you to develop the technique to hold them together with rubber bands? And have you developed any sort of techniques or jigs to help get them together in the first place, or do you just sort of hope and pray as you do it?
The assembly is a bit of an art, because when they're half assembled, they tend to fall to pieces really easily. So I don't use any jigs, but what I do, you sort of create a ring of pieces, and that will sort of lie flat, but also have some stability, and then you can sort of piece the other pieces together onto that. It took me a while to develop the technique. Like, I first tried gluing, and then I started putting alignment holes in, and then I actually discovered the rubber band technique by accident. I was having trouble, like, just holding pieces in place while I glued them, and so I put a rubber band around the outside, and then I thought, oh, if I can just put the rubber band on the inside on hooks, then I don't even need to glue. So that's what I did.
Now, Ralph, you told me about this project before, but I think other people would be interested to know how you actually came to those shapes, because I think that's actually the more interesting part of the story.
Okay, well, a long time ago I did a doctorate in mathematics, so it's the sort of thing a mathematician knows about. If you look on Wikipedia, you'll find tables of various polyhedra and classifications. Yeah. So the code to generate them is written in OpenSCAD, which is basically a programming language for 3D shapes. Probably not great for sort of engineering projects, but where you're doing sort of algebra to generate coordinates and so on, that's perfect.
Awesome. Cool. Thank you so much, Ralph.
Yeah, I'm Aleksandr, or just Sasha for short. This is one of my first events, sort of like attending, where people show stuff like this. This has been really awesome. Thank you all. I'm a first year electronic and sort of electrical, the degree is shared, engineering student at AUT. This is my first year, just out of high school, just sort of beginning to learn all about this stuff. It looks very interesting so far. Up on the table there, I bought a very old, if I hold it up, it's probably going to fall to pieces, held together with hopes and dreams and duct tape, lots of red duct tape. It's a very old, probably from the 60s or 70s, analog multimeter. My friend's dad is an electrical engineer for 30 years, and he's just had a lot of stuff built up over the time where it was just sitting in a shelf, and he said, if you can fix it, you can keep it. I've been trying. It's one of my, not my totally first hands-on experience with electronics, but this one I hope will turn on after I touch it. A lot of stuff that I touched before did not turn on afterwards.
Me too.
Live and learn, right? Yes, so there's schematics there that I scrounged from like the Dutch web because it's a Dutch model or something. Thank you, Google Translate, because otherwise I wouldn't be able to like read any of the instruction manuals. Please, if anyone knows anything about this stuff, or even just willing to help reading the circuit schematics or looking at the circuits or anything like that, I would really appreciate some help. I just want to fix this thing.
Well, I think there's a lot of people here that can help you with that.
If anyone's looking for an intern, I may break things, but I'm a quick learner.
Yep.
Happy to talk. I don't have any socials.
I speak both a little bit of Dutch and a little bit of electronics, so
happy to have a chat.
Awesome.
Thank you so much.
Sweet. Thank you.
Hi guys, my name is Talha Ashraf. This is my second hardware meetup event. I love coming here because it's hardware, not just software. I'm a final year computer systems engineering student at UOA. I love embedded systems, so anything that's like this, PCB design, firmware, super into it. Short term, I'm about to graduate. I'm looking for graduate roles. Long term, I've got this dream that I can bring some sort of repairable and totally forgot the word. You know the thing Framework does, Framework laptop, they have modular. I love modular stuff. I don't know if you know about Google's Ara phone. That's kind of what sparked this in me. For years and years and years, I want a modular phone. And I think we can start off with things that aren't as complex as phones, maybe headphones, maybe lamps, smart lamps, things like that. I'd love to do that in the future. Yeah, that's me. Cool. Thank you guys.
Thank you. So first of all, very much a big thank you to Outset, Blender, and GPC, our sponsors for tonight. Thank you so much for helping us run this event. We couldn't do it without you. Thank you to everyone that spoke. Thank you to all of you for coming along.